And so we come to the very last question of that stoichiometry review quiz. A little bit of everything. We're going to have to find some moles. We're going to have to figure out a limiting reactant. We're going to have to figure out theoretical yield so we can solve for our percent yield. All kinds of crazy stuff going on here. So here is our problem. And we're going to start with our balanced equation. So single replacement reaction between aluminum and copper 2 chloride dihydrate. So aluminum and copper with a charge of 2. That's what that 2 tells us. Chloride's a charge of -1. So I know I'm going to need 2 chlorines to go with my copper. Dihydrate means that I have 2 water molecules stuck to each formula unit of that copper 2 chloride. And that is going to produce some stuff in a single replacement reaction. Single replacement, these 2 metals are going to trade places. So aluminum will be stuck to chlorine. Aluminum has a charge of +3. Chlorine's still a -1. So I'm going to need 3 of those to balance it out. And if aluminum's on the chlorine, that means that copper is now single. And we're also going to have those waters pop off and float around in our beaker. So let's go ahead and balance our equation. Erase that funky mark real quick. And so balancing, I have 2 chlorines and 3 chlorines. My least common multiple is going to be 6. So I'm going to do 3 and 2. So now I have 6 and 6. If I have 3 coppers, I need 3 coppers. If I have 2 aluminums, I need 2 aluminums. I have 3 times 2 is 6 waters. Balanced equation is done. Next up, we're going to go ahead and look at our 2 reactants. I have 4 grams of aluminum, and we have 30 grams of copper 2 chloride dihydrate. And we need to turn these both into copper because we need to figure out what theoretical yield to use. So steps 1 through 12 or so, we're going to turn our aluminum into copper. So 4 grams of aluminum. We're going to get rid of aluminum's grams by using the molar mass, 26.982 according to the periodic table. That's how many grams are in 1 mole of aluminum. Grams are gone. Now I want to get rid of aluminum. I'm going to put aluminum on the bottom. I want to turn it into copper. Aluminum's number is 2. Copper's number is 3. So now aluminum is gone. I have moles of copper. I don't want moles of copper. I need grams of copper. And so I'm going to put my moles on the bottom so that they go away. Moles on top, moles on bottom go away. How many grams in 1 mole of copper according to our handy dandy periodic table? Well, that would be 63.546 grams per mole. So I have grams of copper left, which is great because grams of copper. And all I have to do is some math. 4 divided by 26.982 times 3 divided by 2 times 63.546. And that's going to give us, with sig figs, 11 grams of copper. Now we need to do the same thing with our 30 grams of copper 2 chloride dihydrate. So first step is to get rid of those grams, turn our grams into moles. This one's a little trickier to calculate the mass of because I need 1 copper, 63.546. I need 2 chlorines, 35.453. I actually need 4 hydrogens and 2 oxygens. Add all those up and we get 170.48 grams per 1 mole. So now grams are finally gone. We're going to turn our grams into moles. I have moles of copper 2 chloride. I don't want grams of copper 2 chloride. I want grams of copper. And so I'm going to put my copper 2 chloride dihydrate on the bottom. copper on the top because that's what I want. Look at my balanced equation. I have 3 and 3. Then I need to turn my moles of not copper 2 chloride. We canceled that out. My moles of copper, I need to turn those back into grams. So we're going to do that by putting our moles on the bottom so that they go away. Grams on the top, that's what I want. How many grams in 1 mole of copper according to the periodic table? 63.546 yet again. And so now my moles are canceled out. I have grams of copper. This is what I want. Do that math. 30 times 1 divided by 170.48 times 3 divided by 3 times 63.546 divided by 1. And we get, oh dear, we get 11 grams of copper because I actually did this math wrong. It should have been 14. I was looking at the wrong answer. My bad. So back up the video a little bit. If you were like, how did she get 11? I didn't get 11. I got 14. So sorry. So 4 divided by 26.982 times 3 divided by 2 times 63.546 is 14 grams of copper, not 11. I was looking at the wrong part of my paper. This one, 30 divided by 170.48 times 3 divided by 3 times 63.546 is actually, in fact, 11 grams of copper. So if I use up all my aluminum, I can make 14 grams of copper. If I use up all my copper 2 chloride dihydrate, I can make 11 grams of copper, which means that I can really only make 11 grams of copper. I don't have enough copper 2 chloride to make 14 grams. So what we are going to use is this for our theoretical yield, because this really is the most copper I should make if I mix together 4 grams and 30 grams. So back to our formula, percent yield, which is actual over theoretical times 100. Our actual yield given to us in the problem was that 7.4 grams. We're going to divide that by the 11 from my limiting reactant of copper 2 chloride. So 11 grams times 100. And we do that math. 67.3 is our theoretical yield. And that, my friends, is the end of tonight's show. Good luck studying. I will see you soon.